Question number 2. Construct the table of variation of each of the following function and find local maxima and minima. F prime of x equal to 3x power 2 over 3 minus 2x minus 3. Reduce 3 with 3 equal to x power 2 minus 2x minus 3. Set it equal 0. Analyze by experiment. X, negative 3, positive 1 equals 0. Either x minus 3 equals 0, then x equal 3, or x plus 1 equals 0, then x equal negative 1. We have two critical points. Construct the table of variation. This is the value of the critical point, negative 1 and 3, and this is the sign of first derivative. When x less than negative 1, take negative 2 square, 4 plus 4 minus 3, it is positive since 8 minus 3 is 5. Between negative 1 and 3, take 0, 0 minus 0, 0 minus 3, then the sign is negative. After 3, take 4, 4 power 2 minus 8 minus 3, 16 minus 11, it is positive value. Therefore, the function here in this interval is increasing, in this interval decreasing, and here is increasing. Therefore, f of negative 1 equal to 5 over equal to negative 1 cube over 3 minus negative 1 square minus 3 times negative 1 equal to 5 over 3. Then the point negative 1, 5 over 3 is local maximum point for this function. And f of 3 equal to 3 cube over 3 minus 3 power 2 minus 3 times 3 equal to negative 9. Then 3 negative 9 is local minimum point for this function. Part B, f of x equals sine square x in the open interval negative pi over 2 to pi over 2. F prime of x equal to 2 sine x times cosine x equal to sine 2x. Set it equals 0. Then set 2x equals sine of 0 n pi, where n is integer number. Then x equal to n pi over 2. Now, when n is 0, x equals 0, 0 is within the interval of the question. When n is 1, x equal pi over 2, and negative pi over 2, it is not within the interval of the function. Therefore, we have only one critical point. Set it in the table. This is negative pi over 2, and this is pi over 2. And the graph of sine is from 0 to 2 pi periodic function. Between negative pi over 2, this is negative pi over 2, and this is pi over 2. Between negative pi over 2 and 0, take negative pi over 4. Sine 2 times negative pi over 4 equal to sine negative pi over 2 equal to negative sine pi over 2, since sine is odd function. Sine of pi over 2 is positive. Positive times negative then the value here, the sign here is negative. Between 0 and pi over 2, take pi over 4. Pi over 4 times 2. Pi over 2 sine pi over 2 is positive. Therefore, the function here in this interval is decreasing, and from 0 to pi over 2 is increasing, and f of 0 equal to sine 0 is 0. Therefore, 0, 0 is local minimum point for this function. Question number 3. Identify the points of inflection of each of the following and discuss the concavity of each graph. F of x equal to x power 3 minus 3x power 2. The first derivative, f prime of x equal to 6x power 2 minus 6x. The second derivative will be f double prime of x equal 12x minus 6. Set it equal 0. Factorize by 6. 2x minus 1 equals 0. Divide both sides by 6. Then 2x minus 1 equals 0. Then 2x equal 1. Then x equal to 1 over 2. We have one critical point, one possible inflection point. Find the sign of the double prime before and after this critical point. Before 1/2 take 0, f double prime will be 0 minus 6 minus. After 1/2 take 1, 12 minus 6 is positive. Therefore, the function is convex between negative infinity to 1/2, negative infinity to 1/2 open interval. The function here is convex, and in the interval 1/2 to positive infinity, the function is concave. And the point f of 1/2, substitute it in the function, you will find that it is equal to negative 1/2. Then the point 1/2, negative 1/2 is an inflection point for this function. Part B, f of x equal to cosine pi x. F prime of x equal to negative 2 pi sine x, and double prime of x equal to negative 2 pi, pi x, negative 2 pi square cosine pi x. Set it equals 0. Divide both sides by negative 2 pi square. Then cosine pi x equal to 0. Set pi x equal to zeros of cosine pi over 2 plus n pi, where n is integer number. Factorize the right side by pi, then pi times 1/2 plus n. Reduce pi with pi, then x equal to 1/2 plus n. Therefore, x equal to, when n is 0, x is 1/2. When n is 1, x is 3 over 2. It is within the interval. When n is 2, x is 5 over 2 is greater than 2. Therefore, we will take only these 2 points. Find the sign of the double interval between after and for these values. This is 0, this is 1/2, 3 over 2, and 2. Now, this is the graph of cosine from 0 to 2 pi. In the middle, we have pi, the zeros of cosine, pi over 2, 3 pi over 2. Between 0 and half, we take 1/4, 1 over 4. Substitute 1 over 4 in the second derivative. Pi over 4, cosine pi over 4 is positive. Positive times negative, it is negative. Between 1/2 and 3 over 2, take 1. Cosine pi is negative. Negative times negative, double prime is positive. Between 3 over 2 and 2, 7 pi over 4, it is less than 2 pi. The value is positive. Positive times negative, the sign is negative. Therefore, function is concave between 0 and 1/2 open interval, and between 3 over 2 and 2. Here the function is convex, and in interval 1/2 3 over 2 the function is concave, and the point 1/2, substitute 1/2 in the function. Cosine pi over 2 is 0, therefore 1/2 0 is an inflection point for this function. 3 over 2, 3 pi over 2, also cosine 3 pi over 2 is 0, therefore also 3 over 2, 0 is an inflection point for this function. Question number 4, find the value of a, b, and c, knowing that the graph of the function f of x equal ax power 3 plus bx power 2 plus c has point of inflection at x equal -1 and a tangent line y equal -3x minus 1 at that point. Since the function has a point of inflection at x equal -1, then f double prime of -1 is 0. Find f prime of x equal to 3ax power 2 plus 2bx, and the second derivative f double prime of x will be 6ax plus 2b. Now, if double prime of -1 equals 0, that is that is 6a times -1 plus 2b equals 0. Therefore, -6a plus 2b equals 0. This is the first equation. Also, the function has tangent line with the equation y equal -3x minus 1 at that point. That is mean the derivative of the function at this point equal to the slope of the tangent line. The slope of the tangent line is -3, and the slope of the function at this point equal to the first derivative of the function at this point. F prime of -1 equal to 3a -1 squared plus 2b times -1 equal to the slope of the line equal to -3, the slope of the line, -1 power 2, 1, therefore 3a minus 2b equal to -3. This is the second equation. Solve the first and second equation to find the value of a and b. -6a plus 2b equals 0 and 3a minus 2b equal to -3. By addition, 2b minus 2b 0, minus 6a plus 3a, -3a equal to -3. Therefore, a equal to -3 over -3 equal to 1. Substitute the value of a in the first equation to find the value of b. -6 times 1 plus 2b equal to 0. Negative 6 plus 2b equals 0. 2b equal to 6. Therefore, b equal to 6 over 2 equal to 3. This is the value of a and b. Now, find the y-coordinate of the tangencity point. Since we have the x-coordinate, substitute x-coordinate in the equation line to find the y-coordinate. Y equal f of x equal to negative 3x minus 1. Therefore, f of negative 1 equal to negative 3 times negative 1 minus 1 equal to 3 minus 1 equal to 2. Therefore, the point of tangencity is negative 1 by 2. Since the point of tangencity belongs to the graph of the function of, therefore, it is satisfied the function. F of negative 1 equal to, the value of a is 1. 1 times x power 3 negative 1 power 3 plus the value of b 3 times negative 1 square plus c. 2 equal negative 1 power 3 negative 1. 3 times negative 1 square 3 plus c. Therefore, 2 equal to 2 plus c. Therefore, reduce 2 with 2, c is 0. The value of c is 0 and the function will be x power 3 plus 3x power 2. Question number 5. True or false? The point 1, 0 is an inflection point for f of x equal x minus 1 power 4. This statement is false. Since f prime of x equal to 4x minus 1 to the power 3 and f double prime of x equal to x minus 1 to the power 2. And this function is always greater than 0. Therefore, the function is not changed from convex to concave. It's always positive. It's always concave. Therefore, the point 1, 0 is not an inflection point for this function. If f double prime of c greater than 0, then the slope of the tangent line to the graph of the function at x equals c is positive. Also, this statement is false. Since we take f of x equal to x power 2, then the first derivative is 2x and the second derivative is 2. If we take c equal negative 2, therefore, then f double prime of negative 2 is 2 greater than 0. And f prime of negative 2 equal to 2 times negative 2 equal to negative 4. Therefore, the slope of the tangent line to the graph of the function at this point is negative. It is not positive. Question number 6. Determine each limit. Limit x approach to positive infinity for 1 minus 2x or power 2 over 2x or 2 plus 1 equal to limit x approach to positive infinity. To find this limit, we need to open this bracket. 1 minus 4x plus 4x power 2 over 2x power 2 plus 1. Since the degree of the numerator and denominator are equal, therefore, the answer is the coefficient of the leading term in the numerator 4 over the coefficient of the leading term in the denominator 2 equal to 2. Number B, limit x approach to negative infinity for 1 over 2x power 2 minus 1 plus 3x equal to limit x approach to negative infinity for 1 over 2x power 2 minus limit negative 1 when x approach to negative infinity plus limit 3x when x approach to negative infinity. Equal to. For the first term, the degree of the numerator is less than the degree of the denominator. The result is 0. For the second term is the limit of constant, therefore the value of the constant. For the third term, substitute every x with negative infinity. 3 times negative infinity is negative infinity. Therefore, the answer is negative infinity. For the third question, our third part, limit x approach to negative infinity for 2x power 2 minus x minus 1 over absolute value x minus 2. To find this limit, we need to remove the absolute value. We use the definition of the absolute value. Absolute value x minus 2 equal to x minus 2 when x greater than or equal to, and equal to negative x plus 2 when x less than 2. Since x approach to negative infinity, then x is less than 2. We substitute absolute value x minus 2 with negative x plus 2. The limit will be limit to x power 2 minus x minus 1 over negative x plus 2 when x approach to negative infinity. Since the degree of the numerator is greater than the degree of the denominator and the power is even, therefore negative infinity power 2 is infinity times 2. The answer is positive infinity. Question number 7, use the graph to complete the following table by using plus, minus, or positive, negative, and 0. X equal negative 2, the value of function is 2, therefore it's positive. F prime of x at x equal negative 2, the function has horizontal tangent line as you see, therefore the value will be 0. F double prime of negative 2, the function here is convex, therefore f double prime should be negative. X of 0, it is 0. F prime of 0, also the function has horizontal tangent line, therefore it is 0. F double prime, the function is concave, therefore will be positive. X equal to 3, the value of function is 2, it is positive. F prime of 3, the function has horizontal tangent line, therefore should be 0. And F double prime, the function has an inflection point at this point, also should be 0. X equal negative 3, this is negative 3. The function is negative under x-axis. F prime of negative 3, the function is increasing, therefore should be positive, the derivative. And f double prime of negative 3, the function is convex, therefore the function is the sign of the double prime is negative. X equal 4, f of 4 is positive over x-axis. F prime of x, the function is increasing, therefore the first derivative should be positive. And f double prime, the function as you see it is concave, also the sign of the double interval should be positive. See you next lesson.